Okay, before we teach you kind of the new step in the process, I want to recap. So, I want this simplified. You got the square root of 8x to the second times the square root of 2x to the second. So both square roots, everything, it's a multiplication problem, everything's in a square root, okay? So I make a 1/2 power, then I multiply. 8 times 2 is 16. 2 plus 2 is 4, so 16x to the 4th. So now simplify using your exponent properties. So you got 16 times x, okay? Remember, when you got these rational exponents, there's 6 things you have to look at as opposed to the whole exponent, the integer exponents, where there's only 3. So 1 times 1/2, and then 4 times 1/2 is 2. Okay, now, no negatives, don't have to worry. Carry over your x to the second, that's your whole. Your rational, you carry over and circle the bottom because you want to do a root check. Okay, so a square root. So 16's right there, and that's there. It's equal to 4, so we get to get rid of the rational exponent, and now it's an integer exponent, 4 to the 1st. So I don't have to worry about the bottom. Okay, so I don't need to draw a radical because it's nothing but integer exponents. There's no fraction, no rational exponents. So you got x to the second times 4 to the 1st. Okay, 4 to the 1st is 4, and then x to the second. Next one, 5 cubed root of 9y to the second times the cubed root of 24y. Okay, so it's a multiplication problem. So I put the outside factor first. If there would have been another outside factor, I'd multiply it, but there wasn't. Now I make one quantity with a 1/3 power, and I take 9 times 24, which is 216. Then y to the second times y to the first, which is y to the third. Okay. So we have 5 times 216 times y. Okay, so it's 5 to the 1st. It'll just stay 5 to the 1st. 216 to the 1st. 1 times 1/3 is 1/3. Okay, y. 3 times 1/3 is 1. Okay. So we position the integer exponents, these two. 5 to the 1st times y to the 1st. And then your rational exponent, remember to circle the bottom on the rational exponent and do a root check, because that means cubed root. Oh, 216's here, man, lucky day. So that now becomes 6 to the 1st. So, we've got, again, we have 5 to the 1st. We got y to the 1st. We got 6 to the 1st. We don't need to make a radical because there's no fraction exponents, no rational exponents. So 5 to the 1st is 5, then do the 6 to the 1st, that's 6, and then y to the 1st is just y, and 5 times 6 needs to be multiplied, and it's 30, so 30y. Okay, next one, we've got 2 with a 4th root, and in the 4th root we have 81x to the 5th, y to the 4th, times 2. Got a 4th root, and in that second 4th root we have 32x to the 3rd, y. So it's all one multiplication problem, so we multiply the outer factors, the 2 and the 2. That's 4. Now when I get to the radicals, they both are a 4, so make one quantity to the 1/4. 81 times 32, that's going to be a big number. 2,592. Okay, then x. Okay, x to the 5th, x to the 3rd would be x to the 8, and then there's also leave room for y. Y to the 4th times y to the 1st, so that would be y to the 5th. Okay. Okay, so you got 4 times 2592 times x times y. Okay. Let me do that. 81 times 32. I want to make sure that, yep. Okay, so 4 is just going to be the first. That's not part of the expression there. Now, 1 times 1/4 is 1/4. 8 times 1/4 is 2. 5 times 1/4 is 1 1/4. Okay. So position your whole exponents. You got a 1, a 2, and a 1. So I'm going to have 4 to the first, x to the second, y to the first. Now put your rational exponents times 2592 to the 1/4 times y to the 1/4. So circle those 4s. So we're going to do a root check on the 4th root. Is 2,592 there? No, it's not. Okay, and y is not going to be there. So we don't get lucky that time. Okay, so we got 4 to the first, x to the second, y to the first. And when you get to the rational exponents, you make 1/4 root, and inside you put 2,592 times y to the first, or y, and then simplify. 4 to the first is 4, x to the second is x to the second, y to the first is y, and then I make my radical with a 4. Y stays in there, the y that's there stays, and then I need to break down the 4th root of 2592 if possible. Okay, so 2592, you'd start at 2401, not going to work. 2592, then you divide by 1296. That worked, okay? So 1,296 and 2. So the 2 stays in. The 4th root of 1,296 is 6, okay? So you put a times 6 there, and then 6 times 4 is 24. Please multiply that. So that's your answer. 24 times x to the second times y times the 4th root of 2y. Okay, I got the cubed root of 6 times the cubed root of 16. So 1/3 power, 6 times 16 is 96. So we have a 96. It's just going to be the 1/3 power. So that's the only base I got, and it's got a rational exponent. Do a root check. 96 ain't here, so it's not going to go away completely. Okay, now that's the only base I have. It's got a rational exponent, so you need to make a cubed root, and then 96 to the first would just be 96. Now you see if you can simplify that. Okay, you're on your cubed roots. So 96 divided by 64, nope. 27, nope. 8 works, 8 and 12, okay? So 12 stays in the radical. The cube root of 8's 2. That comes out, okay? So 2 cube root 12. Okay, now let's recap division, okay? We've got, just a second, I gotta check and see if I wrote that down right. Yep, I did. Okay, these are square roots since they don't have them. So on top you got the square root of 56, x to the 5th, y to the 5th. On bottom you got the square root of 7xy. So you make 1/2 power. 56 divided by 7 is 8 on top. X 5th, x first. You'd minus 1 from x to the 5th, and that's x to the 4th. Y 5th, y first. Minus 1, that's y to the 4th. Okay, so we got 8x and y. So 1 times 1/2 is 1/2. 4 times 1/2 is 2. 4 times 1/2 is 2. Okay, you don't need that because you don't have any negatives, so you bring over your whole exponents. And the rational you bring over, but you need to circle the bottom. Now do a square root check. Okay, it's square because it's a 2. 8's not here, so we can't simplify it like that. Okay, now x second, bring down your integer exponents. Now your rational, you now make that into a square root. Okay, and inside you're going to have 8 to the first. So x to the second, y to the second, then I make a square root, and I need to break that down if possible. Well, I think 8's divisible by 4, isn't it? What's 8 divided by 4? It's 2. So that 2 will stay here, but the square root of 4 becomes 2. So 2x to the second, y to the second times the square root of 2. Okay, next one, we have a fourth root, and inside the fourth root we have 162x to the fourth over 2y to the eighth. Remember, it doesn't matter whether it's two separate roots or just one full one. It's done the same way. Okay, so 1/4. 162 divided by 1 is 81. X to the fourth, I got nothing with that, and y to the eighth, I've got nothing with that. Okay. (81) times x to the fourth, y, well, my bad, okay, 81 times x times y. So 1 times 1/4 is 1/4. Now 4 times 1/4 is 1, 8 times 1/4 is 2. Okay, so the integer ones are 1 and 2, so x to the first, y to the second. You put that y to the second on bottom. Then you bring over the 81 to the 1/4 power, and you do your root check. You're doing a fourth root check. That's equal to 3, so this now goes away, and I have 3 to the first. Okay. You actually have an exponent on bottom, but it's an integer exponent. Okay. You're not allowed rational exponents on bottom, and we'll be getting into that in the next video. Okay, so I don't need to make any radicals now. I just got x to the first times 3 to the first, y to the second, because there's no bottoms. Okay, so 3 to the first is 3. Do your number first. X to the first is x, and y to the second. Okay, now last one. This is kind of a bit different. Okay. Yeah, it is. Puts 2, 2. So it's the square root of 20ab divided by the square root of 45a squared b to the third. A to the second, b to the third. Okay, now 20 divided by 45 is a decimal. We don't want decimals, okay? You don't want to put that. So what you do instead is reduce. You'd look up 20 and 45 on a multiplication table. They're both in row 5. So you would divide each of these by 5. So that would become a 4, and that would become a 9. So 4/9. Okay, my bad. It'd be a 1/2 power. And it'd be 4 over 9. So you'd reduce it. Now, a to the first, a to the second. Cross out your a to the first, minus 1 from down there. So it'd be a to the first on bottom. Okay. And then b to the first, b to the third, I do the same thing. I minus 1 from the 3, and it's b to the second on bottom. Okay. So again, that when it doesn't divide just perfectly, I need to reduce it. Okay, so we got 4. That's the only base on top. Then I got 9. Actually, hold on a second. Don't do this problem. You haven't learned this yet, okay? Because you have something you have to deal with. That's coming up. Don't do that problem.